This is Mr. Anderson from Kellogg Community College, and today we're looking at part 2 of our three-part video talking about all these kind of problems that have multiple radicals in them. They have several radical terms, and we are going to try to get rid of the radical in the denominator. But what makes this challenging is that your denominator is a binomial. And since your denominator is a binomial, we cannot just multiply simply to get rid of one of your two pieces of the denominator. Now, just like we do in our previous problems where we rationalize the denominator, we have to multiply by 1, which means we multiply the top and bottom of this fraction by the same thing. Now, here's the trick. Like in problem 10 on the previous worksheet, or on the other side of this worksheet if you're working from that, or if you saw the video, the previous video, you'll notice that this is a square root of 2 plus 3. Well, if we take the square root of 2 minus 3, square root of 2 minus 3, this is going to be a way to get rid of the square roots in the denominator. Now, our numerator is pretty straightforward, and that is going to be 5 square roots of 2 minus 15. Now, our denominator has to be FOILed. So our first bracket here, or first branch here for the first terms, square root of 2 is going to be the square root of 4. The square root of 2 times the negative 3 is negative 3 square roots of 2. The 3 times the square root of 2 is positive 3 square roots of 2. Now look at the middle two terms. This term and this term are going to simplify to 0. And our final term, the 3 times the negative 3, is negative 9. So what we have in our numerator is the negative 15, and I want that to be in front of the radical, which is plus 5 square roots of 2. And then in our denominator, the square root of 4, which is 2, minus 9, and 2 minus 9 is negative 7. And that right there is your answer. Now, sometimes the book will factor out a negative 1, so you might have a positive 15 minus 5 square roots of 2 over positive 7. You will see this happen multiple times, especially when dealing with things like the quadratic formula in the next chapter. Let's look at problem 14. Problem 14, we're going to multiply by 1, and in this case, our denominator is going to be 4 plus the square root of 5. 4 plus the square root of 5. So we're going to go 4 times 4, and I'm just going to do the denominator first here. 4 times 4, which is 16. 4 times positive square root of 5, which is 4 square root of 5. And then 4 times the negative square root of 5, so that's negative 4 square roots of 5. You can see that these will simplify. And the negative square root of 5 times the positive square root of 5 is going to be negative square root of 25. Because since these are using the product rule, since these are both under the square root, the problem will work out that way. Now, in our numerator, we're going to have 5 times 4, which is 20, and 5 times the square root of 5, which is 5 square roots of 5. Now, in my denominator, I have 16 minus the square root of 25, so 16 minus 5. So my numerator is 20 plus 5 square roots of 5 over 16 minus 5, which is 11. Some of you might think, well, I could factor a 5 out of this numerator and make it look like 5 times the quantity of 4 plus the square root of 5. That's okay. It's just, it's unnecessary. Now in problem 15. We have to multiply by 1 again. And when we multiply by 1, what we're going to get is the same thing in the numerator and the denominator. So we're going to look at x plus z. These square roots, the square root of x plus the square root of z on top and bottom, will give us the terms that we need to simplify in the denominator. Now let's focus on the numerator first. Using the product rule, if I multiply these two together, I get the numerator of the square root of xz. Then I multiply this times this. This gives me the square root of z times z, or z squared. We'll simplify that in just a moment. Now let's do our FOIL here. The square root of x times square root of x is square root of x squared. Square root of x and square root of z is positive square root of xz. Negative square root of z and square root of x is negative square root of xz. And then negative times the negative square root of z and the square root of z is negative square root of z squared. Now these middle two terms simplify. In my numerator, the square root of z squared simplifies, so z is brought out of this term here. And then that leaves me with the xz just trapped inside of this square root because there's nothing we can do to pull that out. In my denominator, the square root of x squared is x, and minus the square root of z squared is just z. And that is my simplified answer to the problem. Last one, problem number 16. Well, this one's going to be a lot of work here because there's going to be a lot of FOIL in top and bottom. So we're going to multiply the top and bottom by 2 square roots of 3 plus 5 square roots of 2. So it's exactly like the denominator, except that you have to use the opposite symbol. 2 square roots of 3 plus 5 square roots of 2. So let's start foiling. Now I'm going to choose different colors for the numerator and the denominator. So let me quickly change the numerator to light blue. So if I'm going to look at 5 square root of 3 times 2 square root of 3, this makes 10 square roots of 9. That square root of 9 will be simplified. Plus 5 square root of 3 times 5 square roots of 2 is going to be 25 square roots of 6. The square root of 6 cannot be simplified. The negative square root of 11 times the 2 square roots of 3 is negative 2 square root of 33. The negative square root of 11 times the positive 5 square roots of 2 is going to be negative 5 square root of 22. Now I'm going to change to another color for my denominator. I'm going to take my denominator here after I draw my little division symbol there. I'm going to change this to green. So let's look at this. Now I've got 2 square root of 3 times 2 square root of 3, which is going to be 4 square roots of 9. The 9 will be simplified. Then 2 square roots of 3 times the 5 square root of 2, which is going to be 10 square root of 6. Hold on a second here, just making sure I got my numbers right. 2 times 5. Yeah, okay. And then negative 5 and the 2 is going to be negative 10 square roots of 6. As you see, these two will simplify. And then finally, negative 5 and positive 5 is negative 25 square roots of 4, which will be simplified. Alright, now it's time to do the simplification game. I'm going to change colors again here so you can kind of follow what I'm doing. Let's go to red here. Now, the 10 square root of 9 is more like 10 times 3, so that's going to be 30. Now, these three terms here are not going to be simplified at all, so we're just going to change this to, let's put negative 2 square root of 33 next, minus 5 square root of 22 next, plus 25 square root of 6. Sorry that got so squished there, but you'll see that there's really nothing we can do with these these radicals here. They cannot be simplified because 33, 22, and 6 both cannot be simplified by any of our radicals. Now down below, 4 times the square root of 9 is 4 times 3, which is 12. And the negative 25 times 4 is technically negative 25 times 2, so that's negative 50. So 12 minus 50 is negative 38. And this, in red, is our final answer to the problem. All right, well, thanks for watching.